Hello, my name is Caleb Horst with CellScale Biomaterials, and I'm here today with Dr. Theo Seiler at the IROC Institute in Zurich, Switzerland. Thanks for joining me, Theo. Could you tell me a little bit more about your research and what it is you're hoping to accomplish?
We are doing our research in ophthalmology, in the disease of keratoconus. The disease is where the cornea gets weaker and weaker, and we try to make the cornea stiffer and stiffer. The way we do this is we just apply riboflavin onto the cornea and then do some UV radiation on it, and due to that the cornea gets stiffer and stiffer. And right now we are doing some investigation how we can do it much more comfortable for the patient and easier for us. And another fact is that we want to get more crosslinking, so it gets more stiffer. And this is the reason why we use your machine to measure the stiffness of the cornea. And right now we are doing it with pig's eyes, because this is much more easier for us, because if we do it with human eyes, this is then the next step where we want to do it.
Right, I see. Can you tell me a little bit more about setting up a test and what you're doing with the specimens and how you're preparing them?
Okay, so first of all we have this pig's eye here, or the eye of the pig. You see it here. Then we do the treatment, what we want to do, applying some riboflavin on the top, or just doing the application, what we do, what we want to do some radiation on it, or just the thing that we want to do. When we have done that, we just cut out a piece of the cornea. You have it already here. This is now, the width is 3 millimeters, and this is already then the treated. And if you want to measure it afterwards, we just get it into the machine here, and there we do the stress strain measurements. We first apply a preload of about 50 millinewtons that stimulates the normal eye pressure. Afterwards we do the stress strain measurement, where we want to stress the the cornea for 12%, or we want to do the strain for 12%.
And is that like a physiologically relevant strain? For
oh, well, it just shows the stiffness.
Okay.
You know, we just want to compare always the cornea with treatment and without treatment. And there we just said it's, we will want to see what force do we have to apply to get a strain of 12%.
Right, okay. And presumably, depending on the nature of the treatment, or how much UV exposure, or how you do the injections of the riboflavin, you get differing amounts of stiffness in the cornea?
Exactly. And it's quite good because it measures really precise. I think it's about 1 millinewton that we can measure, so we can already detect very little differences between the different treatments if we use rings in the cornea to get into the riboflavin, or we just apply it on the top, so we can really measure quite really precise measurements. Okay. So this is yeah.
Very interesting research. Thanks a lot for sharing with us today. I appreciate it, and all the best as you move forward with this project.
Okay. Thank you.